estimate population using sample. So you know that the population, the parameter that we are concerned is mu, pi and sigma. How we want to estimate mu, pi and sigma square? We will use sample where we will use the statistic. Okay, so the mu, pi and the sigma square we represent by theta. So theta ni boleh mewakili mu, pi ataupun sigma square. Okay, so here is statistic where statistic adalah estimator untuk parameter. So the estimator for mu is x bar, estimator for pi is p and estimator for sigma square is s square. So we represent these three statistics as theta cap. So in confidence interval, what you need to do is you have to find what is your lower limit and what is your upper limit. So jadinya you punya value akan berada dalam nilai ini sahaja. Cannot less than your lower limit, cannot more than the upper limit. Okay, so illustration is you have the normal distribution like this. So this is normal distribution. Okay, where your lower boundary is here and lower upper boundary is here. This is your confidence interval here. Okay, so the area under the curve here is your confidence level where contain the estimation value. So sinilah ada you punya estimation value. Okay, where the shaded region here is the error yang tak mengandungi you punya estimation value. We call it as alpha. So because we have two shaded region, two area, we divide the alpha by 2. Okay, from the lower limit and the upper limit, you can calculate the width, lebar. Okay, lebar selang. So the interval width can determine your error. Okay, the bigger the width, the bigger the error. So you must have the smaller width so that your error is smaller. So how to calculate the width is the upper boundary minus the lower boundary. Okay, so from the probability, from the probability under curve here, we know that when we do estimation, there always be error. So estimation for the lower limit is the theta cap minus error, and then for the upper limit, theta cap plus error. So because estimation always have error, tak ada pun yang tak ada error. Okay, so from this one, we derive B minus A, you will get 2E. So width also equals to B minus A, upper boundary minus lower boundary. Width also equals to 2 times the error. Okay, how to find the error? Error can get from the formula or the confidence interval. Okay, so our purpose is we want to find this, the confidence interval, the A and B. Okay, how about the hypothesis testing? So the hypothesis testing, we have 5 steps actually. Oops, sorry. Okay, so hypothesis testing ni kita nak test kita punya parameter. Okay, kita buat claim, the state claim, and we want to test our claim. Is it correct or not? Is it we accept or not our claim? Alright, so we call it as hypothesis testing. So in statistical, we want to do hypothesis testing on our parameter. Is it? We claim that mu is equals to 20. So test, betul tak mu ni sama dengan 20? So we will do hypothesis testing. So in your level, our hypothesis testing, we will conduct using R. And then we will use p-value. You will not use traditional approach. Okay, in hypothesis testing, the first step, you must know how to formulate your hypothesis. When you do hypothesis, you must have 2 hypotheses. The first one is your hypothesis. The second one is the alternative hypothesis. Okay, in statistic, when you do hypothesis, it divided by 3. Two tail, right tail, and left tail. Okay, two tail. How you want to know that your hypothesis is two tail? When you look at the symbol. Symbol is equals and unequals. So it is a two tail. Two tail kat sini maksudnya dia akan ada 2 shaded region. Okay, right tail, 1 shaded region on the right, left tail, 1 shaded region on the left. Okay, how you want to know that your hypothesis is right tail? You look at your H1. H1, your symbol is greater than, then it is a right tail. How you want to know your hypothesis left tail? You look at your H1. If your H1 is less than, it is a left tail. So here, if you look at here, two tail alpha must be divided by 2 because you have 2 region. It is very important here because alpha will be related to the p-value. P-value is the smallest significant value. Okay, probability. And then alpha for the one tail cannot be divided by 2 because shaded region only 1. Okay, so step number 2 in your hypothesis testing, you have to calculate your test statistic. We will use the formula. And then step number 3, compute the p-value. So the software will compute the p-value for you. Either you use Excel, SPSS, Minitab or other software, Python ke, R ke, they will give you the p-value. Okay, we will use the software. So step number 4. So always remember this one. Dalam mana-mana keputusan pun, if you do engineering and apa-apa a field pun, the p-value less than alpha or p-value equals to alpha, always reject H null. Apa maksud reject H null? Maksudnya kita tak terima H null ni. Okay, we will accept the H1. Okay, in any decision, kalau ada p-value, significant value ni, if this p-value less than alpha or p-value equals to alpha, always reject H null. And then step number 5, you conclude your hypothesis. You conclude your experiment. Is it you accept your claim or not? You claim yang daripada awal tadi. So this is basically the confidence interval and the hypothesis testing. Right. So from that, you will have this one. Statistical analysis for one population. So sekarang kita nak buat analyzation untuk satu population sahaja. Tetapi kita ada 3 parameter. Mean, proportion and variance. Okay, we'll cater one by one. How you want to estimate population mean using sample? We will use confidence interval. How you want to conduct hypothesis testing for population mean? We will have this one, hypothesis testing for mu. And after that, we will cater the proportion pula, pi. Estimate pi using P, confidence interval. Test the hypothesis of pi. You have this one. And then the other one is population variance. Estimate the sigma square using S square and then do the hypothesis here. Okay, so all these we will conduct using R. All right, so next. Using X bar. There are 3 conditions. First condition is sigma square is known. Apa maksud sigma square is known? Okay, ini penting untuk step number 2. What is step number 2? Kita nak cari test statistik. Salah. Sorry. Saya campur dengan confidence interval. Okay, sorry. This one is for you to find the A and B. Lower limit and the upper limit. The formula. Okay, formula ni yang kita akan masukkan dalam R. Alright, so there are 3 cases that you need to consider. First, sigma square is known. What is sigma square is known? Dalam soalan ataupun dalam you punya case study, dia akan bagi tahu nilai sigma square. The value of population variance is given. When the value of population variance is given, this is the formula to find lower boundary. This is the formula to find the upper boundary. If you look at this formula, X bar is our theta cap. Z alpha over 2 times sigma over square root and this is your E. Okay, tadi saya ada mention theta cap minus E is your lower boundary. Theta cap plus E is your upper boundary. So ini dia punya formula. Okay, where X bar is the sample mean. Z alpha over 2, we will compute from the R. Sigma is your sigma value because sigma is given. And then N is your sample size. Okay, just put in all the values into the formula, you will get the lower boundary and the upper boundary. So that's it. You need to know which condition you want to use, which formula you want to use. Okay, let's say now in the case study or in the question, they did not give you the value of sigma square or sigma. You cannot use this formula. You cannot use this formula. You have to use either this one or this one. So, nak guna yang mana satu? Look at the sample size. If the sample size greater than 30 or equals to 30, use this formula. Okay. If the sample size less than 30, use the third formula. Okay. So the formula here. Normally, we will given you this formula. Kita akan bagi formula ini. So don't worry. But we will use R. So formula ni tak perlu hafal. You just put in into the R. Okay, now look at here is the, you can, tak apa, ini you boleh baca sendiri. Okay, look at the example. This is the first case. Example 5.2.1, estimate population mean. So estimate, when we have the word estimate, it refer to the confidence interval. Estimate population mean, mu, when the population standard deviation, sigma, is known. So sigma is known. Sigma is known, you use which formula? You use the first formula, this one. So now we want to get the confidence interval. So last kali jawapan you mesti A, B. What is your A? What is your B? So look at the question. A packet of baking powder supposed to have a mean weight of 200 gram. The distribution of weight is normal. Dia mesti sebut normal. And the population standard deviation is 7 gram. A random sample of 9 packets of baking powder had the following weights. So we have this data. Construct a 98% confidence interval for the population mean weight of a packet of baking powder. Interpret the result. So look at the question. Construct a 98% confidence interval for the population mean weight of a packet. So now this one is case number 1, right? Case number 1. So let's look at how we want to conduct this. This one is confidence interval. Estimate mu when sigma is known. So where is the sigma? So where is the sigma, guys? Which one is the sigma?
7.
7, correct. Okay. So a packet of
7
baking powder supposed to have a mean weight of 200. So this one is mu.
mu.
Betul. So this one is sigma. Okay. How many sample we have? N is equals to
9
9. So apa nilai yang kita tak ada? Kita tak ada X bar.
bar.
Macam mana nak cari X bar? Daripada data ni, you boleh cari X bar. So dapat nilai ni, masukkan dalam formula, you akan dapat nilai A and B. Itu kalau manually lah. So now let's do interval for one population mean. So example 5.2.1. Open. Alright. So I have data baking powder. Okay. For example, 5.2.1 baking powder, I have data baking powder. Okay, so this is my data. So this is the data. I have 9 packet. So data tadi tu saya masukkan dalam Excel. So this is the data. Okay. First, what I did do is I find the mean of the data. So this one is the mean. Okay. So run it. So the mean is equals to 210.2222. And then sigma is given. Sigma equals to 7. And then n is the sample size. Sample size is 9. Okay, error. Now find the error. So 0.98 is our confidence level. So dalam soalan tadi, dia suruh construct a 98% confidence level. So we will use Q norm. Here is for Z. Okay. And then sigma over square root n. This is the formula. Ini adalah formula daripada soalan formula. Okay. And then left is your lower boundary. A minus error. A adalah mean. Mean minus error. And then right, A plus error. So you just run it. You get the error. Okay. Left. So left, this is the lower boundary. 205.4301. And then this is the upper boundary 215.0143. So you akan dapat left and right. So bear in mind, left is your lower boundary, right is your upper boundary. So how you want to interpret your result? You do like this. We are 98% confident that the population mean weight of a packet of baking powder lies between our lower boundary and upper boundary. Lower boundary 205.34 gram and upper boundary 215.01 gram. So maksudnya kita estimate nilai mu kita. So nilai mu kita sekarang berada di antara 205.34 gram dan 215.01 gram. So kita estimate daripada situ. Okay, kita ambil berapa sampel? 9 sampel je. Kita ambil 9 sampel, kita kira. So kita punya population tu sebenarnya berada dalam 205 sampai 215. Faham tak? So let's look at next example. Case yang kedua. Okay, estimate population mean, mu, kita masih lagi estimate iaitu confidence interval when population standard deviation sigma ni unknown. Kalau dia tak bagi nilai sigma, kita kena consider dua case, n greater than 30 and less than 30. Tengok dia punya sample size. Kalau sample size dia greater than 30, ada cara lain. Kalau sample size less than 30, ada cara lain. So, read the question. A random sample of 55 bulb. So, dia ada sini. So, n is equals to 55. Was selected and the specified brightness were evaluated for each bulb by measuring the amount of electrical current required. So, dia cakap pasal brightness. So, dia measure apa? Dia measure amount of electrical current. So, amount of electrical current. Okay. The sample mean of the electrical current required for the bulb is 280.3. Apa simbol untuk 280.3 ni? What is the symbol for 280.3? Anyone?
X bar.
Correct. X bar. And the sample standard deviation S is equals to 10.3. Ini adalah maklumat yang diberi. Okay. Construct a 90%. So means that our confidence level is 90%. Confidence interval for the population mean and interpret your result. So now from the information given, tak ada pun sigma. So tak boleh guna formula nombor 1. So we will use the second formula. Okay, formula yang kita guna yang ini. This one, second formula. Okay, let's put into our R. Okay, let's put into the R. Example 5.2.2. Okay. First, you define your X bar. X bar is 2x0.3. And then you define your S, 10.3. You define your N, sample size. And then you calculate the error. And then you put the left boundary, X bar minus error. And then you put the upper boundary, X bar plus the error. Okay. You will get the lower boundary is 278.52 and the upper boundary 282.0799. So, we said that we are 90% confident. So, nampak tak dekat sini dia ubah? 0.9 because of 90%. Okay. So, maksudnya sekarang ni current required for the population adalah berada di antara 278.52 and 282.08. Okay, this one is for the second case. So, let's look at the third case. So, third case sekarang ni, sigma unknown, but the sample size is less than 30 here. So, example yang sama, baking powder tadi, tetapi we did not give you the sigma. A packet of baking powder supposed to have a mean weight 200. So, dia bagi mu. A random sample of 9 packet, n equals to 9, they give the data. So, they just give you the n, they give you the data, they give you the mu. They did not give you the sigma. So, sigma is unknown. So, when sigma is unknown, you will have a t-test. So, kita patah balik kepada formula. Tengok dekat sini. Kalau sigma known, dia adalah Z. Maksudnya kita akan guna Z test. Okay. Bila sigma is unknown, dia akan pecah dua. N besar pada 30, dia masih lagi menggunakan Z. Bila N kecil daripada 30, dia menggunakan T. Okay, T test. So, kita panggil dia T distribution. So, sekarang untuk kes ketiga, dia adalah T distribution. So, let's look at how we want to do it in R. So, example 5.2.3. Tadam. Senang sebenarnya R ni. Put in here. Okay. Saya masih menggunakan data baking powder. And then you put this one. T.test X and confidence level kita berapa? Okay, X ni adalah data and then confidence level yang kita nak adalah 0.95. So just run this one. So this is the data just now. Okay, what is the output? So look at here. One sample t-test. Okay. 95% confidence interval. So this is your lower boundary. 204.5116 and the upper boundary is 215.9329. So pendek je coding dia. Okay. So done for the confidence interval. Okay. So now let's go to the hypothesis testing. So done untuk confidence interval 1 mu. So now hypothesis testing. We want to conduct hypothesis testing for one mean. Okay. So look at here. Cara nak tulis hypothesis dia adalah H null, theta belah sini adalah theta naught. Theta naught ni adalah value, theta ni adalah notation. Sekarang kita bercakap pasal population mean. So the notation here is mu. So sebab tu semuanya adalah mu. Okay. Mu naught, sini mesti value. Where can we get the value? From the equation. Okay, this one is step number 1. Formulate the hypothesis. Step number 2. Okay, test statistic. Step number 2, dia ada Z test, dia ada Z test, dia ada T test. Tak keluar pula formula dia. Okay, so kat sini dia adalah dia punya formula. Formula dia, bukan kat sini. Ni. Okay, Z test bila sigma diberi. Z test, sigma tak diberi. Sigma is unknown but the sample size is greater than 30. And then sigma is unknown, sample size less than 30. We will use T test. Ini adalah untuk step number 2. Okay, let's look at example. How to conduct hypothesis testing for one population mean. Okay, test the population mean when the population standard deviation is known. So we will have the word testing. Bila disebut testing, dia adalah hypothesis testing. For population mean mu when population standard deviation is known. Sigma diberi. So, saya masih lagi menggunakan example baking powder tadi. Okay. From example 5.2.1, suppose the sales officer of the company claims that the mean weight of a packet of a baking powder is less than 200 gram. Test the officer's claim at 5% significant level. Okay, sales officer ni dia claim mengatakan bahawa purata berat baking powder tu sepaket adalah kurang daripada 200 gram. Betul ke tak yang dia claim tu? You have to conduct the hypothesis testing. So, can someone give me what is the H null and H1 from this? So, what is your H null and H1 here?
Mu is greater than or equal to 200.
This symbol is mu, right?
Yeah.
Okay. So, what is the value for this symbol?
200.
100, correct. Okay. The keyword here is?
Less than.
Less than duduk dekat H null ke dekat H1?
H1.
H1. So, macam ni. So, kalau H1 less than, what will happen to the H null?
Greater than or equal.
Greater than and equal. So, sini you punya claim. So, dah pandai buat formulation hypothesis. So, ni you punya hypothesis. So, sekarang test. Buat dekat R. 5.2.4. A. Okay, look at here. Saya gunakan data baking powder. Okay, X bar kita punya mean. Nampak tak sini? Mu 0. Ni maksudnya mu naught. Mu naught kita 200. Sigma diberi 7. Sample size 9. Okay, this one is the formula for the Z test. Ni. X bar minus mu naught over sigma over square root n. Ini adalah formula untuk Z test. And then kira Z test. And then p-val here is the p-value. So look at here. P-value here is for left tail. Ini adalah cara untuk cari p-value left tail. P-value right tail lain pula. Okay, because this one is p-value, because this one is left tail, so this one is how we want to find p-value for the left tail. So look at the output here. Yeah, the output. Ting, 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 ting. Z test is equals to 4.3809 and then the p-value is 0.9999. Dia dekat dengan 1. So how you want to write down the solution? Like this. Step number 1. H null mu is greater than or equals to 200. H1 mu is less than 200 because this one is a left tail. Step number 2 is your Z test. Z test is equals to this one. 4.3810. Saya round up to 4 decimal places. So, step number 3, p-value. Suppose p-value ni boleh kita tulis sama dengan 1. 0.9999. So, since p-value equals to 0.9999 or p-value equals to 1 is greater than our alpha, 0.05. So, kalau greater than, we do not reject H null. Kalau dia less than, baru reject H null. So, do not reject H null. So, kalau you reject this H null, what will be your conclusion? The conclusion at alpha 0.05. So, conclusion you apa? You do not reject this one. So, means that you accept this one. Population mean weight is not less than 2. Okay, soalan ni. Nah, B. For example, yang sama, suppose the sale of packing company claims that the mean weight of packing powder is more than 200. So, sekarang dah berubah dah. Apa dia punya hypothesis? Hypothesis adalah H null mu, H1 mu. 200, 200. So, more than is H1. More than is H1. So, sini. Ni less than. So, kalau dia sini more than, dia adalah right tail. So, macam mana kalau kita nak conduct right tail pula? So, buka sini. Conduct right tail. 5.2.4b. Okay, dia sama je macam A tadi, tapi yang berubahnya dekat sini. Nampak tak dia tulis? Lower tail false. Kalau A tadi, lower tail true. So now lower tail false. So just run this one, you will get the p-value. So p-value is 5.908085 E negative 06. Apa maksud dia ni? Berapa sebenarnya nilai p-value ni?
Really small. 0.00000.
Yes, 0.0000590885. So, always take for decimal places. So, dia kepada 0.0000. So, these are the solution. Okay, since our p-value 0.0000, since p-value 0.00 less than alpha 0.05, we reject the H null. So now, padam H null ni sebab you reject H null ni. So what will be your conclusion? At alpha 0.05, the population mean weight is more than 200 because you reject the H null. Tak terima dah ni. Jadinya, conclusion yang ini. Okay. So, how about two tail? Tadi dah left tail, ini right tail. How about two tail? Okay, kalau two tail, macam mana soalan dia? Macam ni. For example, 5.2.1, ini claims that the mean weight package method is 200. is. The keyword here is is. So keyword here is, symbol is equal. When the symbol is equals and unequal, it will be a two-tail. Okay, kalau two-tail, what we did is, sebenarnya you boleh je cari dalam Google, banyak jugalah coding. Ada macam-macam cara. Point C. Okay, two-tail will macam ni. Okay, lower tail false and 2 times here. This one is the p-value for the two-tail. If you look at here, we get the p-value two-tail still 0.0000. So these are the solution. Right, so we have done for the first parameter, mu. Is there any question?